Hello, so today we are going to do this problem, which is part of Leetcode April Daily Challenge. It's longest zigzag path in a binary tree. So basically here we have a root of a binary tree, and we have this definition of a zigzag path where basically you choose any node in your binary tree, and then you choose a direction to go in, either right or left, okay? And if your current direction is right, then you move to the right child. If it's left, you move to the left child. Okay, and you have to change the direction. So if to arrive at this node you went left, then your next move should go right. And if you arrived from the right, your next move should go left. And then you repeat this until you can't move in the tree, which basically means you arrive at a leaf node. And basically the length is defined, of course, as just the number of nodes you visit along a path, and the goal is to return the longest zigzag path we can achieve. And so let's take a look at this example. So we have this tree. What's the longest path here? Okay, so here, well, you could of course decide to go like this, but then the length would be just 2. You could decide, you can't do this one. You can't go right and then go right again. You can't do that because you have to change direction each time. And so here, the best path is to go right, then go left, then go right. Okay, and now you have to stop. You can't go left. There is nothing left to go to, and you can't go right again because you just went right. And this is the best path, and the length is 3, so we return 3. Okay, so that's the idea. Now let's see how we can tackle it. Okay, so let's see how we can tackle this. Well, when you have a tree, usually you would have to solve it with some kind of traversal, either DFS or BFS, right? And so here there is definitely a DFS solution, but I think with this problem it's easier to solve it with BFS. And so let's look at the solution. So what are we interested in when we get to a node, right? When we get to a node, for example, this node. Well, the main thing we are interested in is how did we arrive here? Because if we arrive at the right, like from this, then the only choice we have is to go left. But what if there was another node, like something here, maybe, right? Maybe this is like a bigger tree with something like this, and then another node like this, right? What if we arrived from the left? In this case, the only place we can go to is to the right. So depending on where you came from, you have only, to continue on the same path, you have only one possibility, right? So that's one observation. So it does matter when you arrive at a node, it does matter where you came from, right? The other thing that matters is that basically, why am I looking at what matters at each node? Well, in BFS, remember, in your queue, you add some values that represent a certain state, and you can use these and update them as you progress. And so that's what we are looking for now. And so here now, what else happens? So if you are continuing on a path, let's say going right and going left and then going right, well, here we want this node to know that so far we did 1 step. We want this node to know that so far we did 2 steps, and we want this node to know that so far we did 3 steps, basically, so that we can count and see if this is the longest path or not. Okay, and so of course, another thing that matters here is the number of steps we did. Okay, so that's another thing that matters. Now, what else matters? So the other thing that matters is, okay, so let's say you arrive here. So you went right, you arrive here. What choices do you have? Well, if you want to continue this path, then you would have to go like this so that you get 2 here. Okay? But the other option you have is just starting a new path, right? Starting a new path. And here you can't add 2. You can't make it 2 because then you would do right. But you can start a new path here, right? With just 1. So you get to this node, you said, I just visited only 1 node, which is this one so far. Okay? So you could do that. And that's actually where the best solution came from, because the best solution is you didn't come from here, right? You didn't come from here and continue it, because then it would be right. We started a new path here. Okay, and so what this basically means is depending on the value of from, you have two choices. One is continue on the same path if you can. Continue on the path that you did so far, which means basically you have to zigzag, or start a new path. Okay? And the other thing, of course, you need for any BFS or DFS state is the node itself, so that you can know what are its left and right child. Okay? So these would be the state for our BFS. And now let's look at these two. So what does continuing on the path mean? Well, continuing on a path depends on the from value. So if the from value is left, then we have to go right. Okay? Then the only thing then for our node, we have to do node.right. Okay, let's actually do it differently. So let's do it for left node and right node. So when we get to a node, right? So when we get to a node, we want to check for if it has a left child, what should we do? Well, if it has a left child, it depends on how we came to that node. If we came to that node from the right, then we can go to the left child. Okay? So basically, if the from value, right, is right, then that means we can continue on this path basically and go to the left side, left. For the next state, where did we come from? Well, we came from going left, so we came from left. And then we can increment steps +1. Okay? And now, what if for the left child, what if the from is from the left side? So that's a case like, so let's see, that's a case like here maybe. If we, let's say maybe we are here, this is right, this is coming right, this is coming left. And so from is right. So let's say here, right, when you are here, you get to this node, you came from the right, okay? And then if you maybe do, let's look at this one. So we came from the left here, okay? And so for this node, we can go right, but what if we had another node like this, okay? We can't do something like this, right? We have to start a new path. And so here we have to start a new path. If we came from the left, we have to start a new path on the node on the left, right? And so here, this means basically for our queue, we have to add, for our BFS queue, node.left, we can go there, right? And we'll tell our next node that we came from the left, but we can't do steps +1 because we are starting a new path. We can't continue on the same path. So here we have to say it's a new path with just value 1 because we just traversed one path, one edge or one side, okay? So we would have to restart at 1. Okay, so that's for the left side. Now what about for the right side? Okay, this is still, and so here you can see we did the two choices. What was the first choice? Well, the first choice is continuing on the same path. This is possible only if we arrive it from the right. And then starting a new path here, which we have to do if we arrive it from the left. Now you may say, why not start a new path here? Well, it's not optimal because if we start a new path here, it's always better to continue the same path because we will increment more, we'll get a higher number here. So it's always better to do this one, so we don't try even the starting a new path if it's possible to extend the existing path. Okay, so I hope that was clear. And this basically means we are adding to our queue for BFS this state so that we can process it next. Now, what about if we come for our right node? Well, again, there, what doesn't matter. So let's take a look here. If we came from for the right node, which means basically we are, for example, here. In this case, if we went from the right, we can't do like this, okay? So we have to start a new path, okay? But if we came from the left, let's say like this, and there was another node here. Then in this case, we went like that from the left, and so we can continue right. Okay, and so let's do that. So if we can, the from value is from the left, right? So this case, then we can continue our path. And so basically what we'll add to our queue is node.right. So we can go right with direction right. So we can go, so here we can go right to our node, this one, only if we came to here from the left. Okay, let me remove this. So we can go to this node by going right only if we came to this node from the left, right? If we came to this node from the right, like here, then we can't go to this node from the right. Again, in the same path, we'll have to start a new path where we start from here and go to the right. Okay, I hope that that was clear. And so in this case, if we came from the left, then we can extend it and go to the right, so we can do steps +1. But if we came from the right, okay, which is, let's say, this case here, then we can't continue and extend the same path. We have to start a new one, and so that's what we do here. And by symmetry also, you could just apply what you did for the left to just make it do the symmetric value each time for the right side, okay? And so here we will add node.right, okay? And we came from the right because this is right node. Sorry, here, yeah, here right node as well. And then what's the step? It's just 1. Okay, this by the way tells the next node where we came from. It's not where we are going, it's where we came from. So for right, it's always right. For left, it's always left. That's pretty much it. So now we know how do we visit neighbors, okay? And the rest is just BFS. And then each time we visit a node, which basically means we extract these values, then we can just check if this is the longest number of steps we have so far. So if this is the greatest number of steps we have so far, then we'll store it in a value, let's call it best, and we'll return that at the end. Okay, so each time we'll take the max against this value. And that's pretty much it. We'll use BFS. Now BFS is O of E plus V, where E is the number of edges, V is the number of vertices. And so that's just the number of elements in the tree, right? And that's pretty much it. So let's code this up and make sure it passes. Okay, so let's implement the solution we just saw in the overview. So what do we need? We need our queue for BFS. So let's call it a DQ here. And we said we need in our queue, we'll put the node where we came from and then the number of steps so far. So let's start that with the root. So first we check if root.left exists, then we want to say let's go to it, right? And so what does that mean? That means we will add root.left, right? And we'll say where did we came from? Well, we are visiting a left, so it means we came from the left. Now how many steps? Well, this is the first step, so it's 1. Now similarly for going for the right side, we can just add right. And where did we come from? Right side, and so we put the number of steps, which is 1. Now we need a best value that will just compute the maximum number of steps we reach, and so we can just return it at the end. And we'll do normal BFS, which is going through the queue, and each time we pop from the front of the queue, so that will give us the node where we came from and the number of steps so far. Okay. And of course, every time we visit, we want to check if this is the max number of steps we have, right? And then now we will try to add both left and right, each with the cases that we saw in the overview. So here we will say if we came from the right, then we can go left, extend the current path. So that means append going left. Okay, we'll tell the next neighbor that we came from the left, right? Because we are visiting a left node, so we came from the left. And we can extend the path because we are doing right, left. So it's a zigzag pattern. Now otherwise, if the from is left, then we can't go we can't go like this and extend the path, right? Because then it would be left. It's not valid. So we'd have to say that we started at 1, that we are starting a new path. So 1 just going from node to node.left. And then we do something similar for node.right. So if we came from the left, then we can go to the right, because it would be left, right, which is valid. So where did we come from? Right, because we are visiting the right node here. And then we can extend the path because this is valid, going from left to right, okay? Now, if from is equal to right, then we want to add node.right, but we can't do right on the same path, and so we'd have to start a new path, okay? And because we went right, we have to set right here. And that's pretty much it. Very straightforward. Now we can, okay, this is just collections, sorry. And that looks good. Let's submit. And that passes our test cases. Okay. Yeah, so that's pretty much it for today's problem. Please like and subscribe, and see you on the next one. Bye.